Hello friends, welcome back to Edupedia Word Videos, your destination to free online education. In this video, we'll start the next chapter, that is applications of trigonometry. We have learnt the different values of sine, cos, tangent of an angle and much more, and some identities. Also, the complementary angles have been discussed in the previous chapter. Now, we will apply the knowledge gained by us on the practical examples, some practical conditions. Friends, trigonometry revolves around triangles. So, in practical situation, say, let us have a situation that a wall, say, defined by a line AB, a person, say, we are viewing this wall, say a person is standing at a point C. Now suppose we know the length, how much tall this wall is, say 10 meters. Suppose by some means we are able to calculate the angle made by this viewer on the top of this wall, say represented by an angle theta. Now we are interested in finding out the distance between this viewer and the base of the wall. So we can find so by the help of trigonometry. Certain assumptions are made, that is, this wall is perfectly right angled with the ground, that is, it is a straight wall making an perpendicular an angle of 90 degrees with the ground, and the observer is generally assumed to be point size unless or until its height is stated in the given practical question or situation. Suppose now we have to find this distance, say BC. How can we do so? Say this angle is 45 degrees. Friends, we know that sine of an angle is perpendicular over hypotenuse, cos of an angle is base over hypotenuse, and tangent of angle is perpendicular over base. So, and there are also some more trigonometric ratios like cosecant, which is inverse of sine. Basically, these are the three trigonometric ratios which we generally deal. So here we are given with perpendicular, this is base and this is height. The only formula that is involving the given value and the value to be find out is this formula, that is tangent of theta is perpendicular over base, or AB over BC. Now we are given the angle as 45 degree. So putting or substituting the values, the height is given as 10 meters and we have to find out BC. We know, friends, that tangent of 45 degree is 1. So the condition becomes like this. So the value of BC on cross multiplication comes out to be 10 meters. So this was a simple or simplest example of practical situation. The terms used are this perpendicular is denoted by P, short for perpendicular. This horizontal distance between the viewer and the base of the thing under study is base. This slanting length is hypotenuse, and this is 90-degree angle. The angle made by viewer on the top of this wall is known as angle of elevation. Now suppose another condition where a person is standing on the wall. He sees an old friend of his from this wall. Say the wall is again of 10 meters, and he sees the person at an angle of 45 degree with the horizon. So now he is interested in how much far he is from the gate of this wall. So again, trigonometry, the application of trigonometry plays its role. Friends, this angle made from the top with the horizontal is known as angle of depression. Now we are acquainted with the formulas or the application of trigonometry inside a triangle, but this is an angle outside the triangle. So first we have to move this angle inside of the triangle. Friends, we know that if two lines are parallel, then if this is an angle P and this is an angle Q, then such that both the angles, they seems like forming a Z, these triplet of line, and the angles are at corners of the Z, then by corresponding parts these two angles will be same. You will study the reason in the chapter triangles. So using this theorem, the angle P and Q here are same, that is 45 degree. Now we have to find out this BC line. So again, tangent of 45 degree, that is Q, is AB over BC. Thus tangent 45 degree is 10 over BC, or BC is 10 over tangent 45 degree, or 10 over 1, such that BC becomes 10 meters. So this was the angle of depression, and a second example, a practical example on applications of trigonometry. Let us have a question. A question says, storm occurs in an area and a tree breaks down such that broken part bends and the top of the tree touches the ground. Suppose we have a tree, say AB. Due to storm, this tree has broken, it bends, and the top of this, say this tree has bent at point P, the top of this B tree is touching the ground. So the condition becomes like this. Now the question says that the top touches of the tree touches the ground with an angle of 30 degree, with ground. So it is making, if this is the ground, then this tree is making an angle 30 degree with this ground. Now the question further demands to find out the height of the tree under consideration. Now the height of the tree is AB. We have to find AB, which is nothing but AP plus PB. Distance, further, the distance between the foot of the tree and the point where top touches ground is 12 meter. This is, my dear friends, the foot of the tree. This is the point where tree touches the ground. The distance has been given as 12 meters. So AB this thing is 12 meters. We have to find out the height AP plus PB. Now, in assuming that the tree was perpendicular, that is straight with respect to the ground, this angle becomes 90 degree. So in right triangle APB, friends, we have to assume the angle 90 degree, because otherwise we can't apply the trigonometric benefits, the trigonometric ratios in the practical situations. So in right triangle APB, PB over AB, that is perpendicular over base. What is it? It is tangent of the angle involved. So tangent 30 degree, because this is perpendicular with respect to the angle 30 degree. So tangent 30 degree comes out to be PB over AB. Substituting the value of AB as 12 meters. Now tangent of 30 degree is 1 over under root 3, which have been the ratios, the values have been discussed in the previous videos in the trigonometric ratios chapter. So PB becomes 12 over under root 3. The purpose or the question has not been over yet. We have also to find AP. Now friends, we know sin theta is perpendicular over hypotenuse, cos theta is base over hypotenuse. We can use any of the two given formulas, the sine and cos, to find out this AP, the hypotenuse, because we have to find out AP and PB, their sum. PB has been no doubt find out over here, but AP is still left. So using sine ratios, we have sine 30 degree equals, friends, what is perpendicular? PB. It is 12 over under root 3, and H we have to find out. Now sine 30 degree, my dear friends, is 1 by 2. So the condition becomes 12 over under root 3 over H equals this thing. Now even earlier it has been told that if the condition is like this, numerator over denominator, where fraction is in the numerator, then we resolve the denominator as numerator into over 1. So it becomes 1 by 2 equals 12 over under root 3. This goes to the topmost part, that is 1, and H will be multiplied by denominator of the major numerator, that is H is here. So finally 1 by 2. Now bringing H to this side, we have H on numerator as this. So now H equals 12 by root 3, and bringing 2 here, it is 12 into 2. So H, or you can say H is AP, comes out to be 24 by under root 3 meters. Now AP plus PB is the height of the tree, which is 12 under root 3 plus 24 under root 3 over under root 3. So taking the LCM, it becomes 12 plus 24 over under root 3, which is 36 under root 3. Or it becomes, friends, this is an absurd form if the under root part is in the denominator. To make it a proper form, rationalize it, that is multiply and divide by under root 3. I have earlier told you that same fraction can be multiplied and divided by same constant. So it becomes 36 under root 3, and under root 3 into under root 3 is 3. So we can further cancel 3 and 36, which will give us 12. So it is 12 under root 3 meters. So friends, the height which we have to find out has come out to be 12 under root 3 meters. This was a practical question on applications of trigonometry. Let us have another question. The question says, there is a statue standing on a base. We have a base and a statue standing over it. From a point on the ground, now base will be on perpendicular to the ground. The question says, from a point on the ground, the angle of elevation of top of the statue is 60 degree. The angle of elevation of the top of the statue is 60 degree, and from the same point the angle of elevation to the top of the base is 45 degree. Friends, this is the base. The angle of elevation to this top is 45 degree. The question demands find the height of the base. So making a free body diagram, simplifying this figure, it becomes, say up till P we have, or up till B we have base AB, and BP is the statue, C is the point of concern from where the angle of elevations are made, and the two angles are 60 degree and 45 degree. Also, the height of the statue is 2.4 meter. It is the additional information in the question. So, the height of the statue, this thing is 2.4 meters. So we have to find out AB in simpler terms. How can we do so? Friends, if we see the triangle, the right triangle PAC and right triangle BAC, we will see that tangent of 60 degree in PAC is PA over AC, whereas in right angle triangle BAC the angle is 45 degree, so tangent 45 degree is BA over AC. Now from the first part, AC is PA over tangent 60 degree, whereas from the second part, AC is BA over tangent 45 degree. Now from equation 3 and 4, comparing 3 and 4, AC's value, we have PA over tangent 60 degree equals BA over tangent 45 degree. Now friends, what is PA? PA is PB plus AB. And tangent 60 degree, we know that it is under root 3. Similarly, tangent 45 degree, we know the value is 1. So substituting this in equation 5, we have PA as PB plus PA over under root 3 equals BA over 1. So on cross multiplying, PB plus BA comes out to be BA into under root 3. Since we have to find out the value of height of base, which is nothing but BA, so we will separate BA, that is PB equals BA under root 3 minus BA, that is PB equals BA common and under root 3 minus 1, or BA equals PB over under root 3 minus 1. Now friends, it is not a rationalized form, so on rationalizing, the denominator, because it is not a like or a perfect fraction, so it becomes PB. The best way to rationalize is to multiply by, or to form the identity a minus b into a plus b, so that we can apply a square minus b square. So it becomes PB under root 3 plus 1 into under root 3 whole square minus 1, that is PB by 2 under root 3 plus 1. Now the value of PB is given as 2.4 meters, so BA becomes 2.4 over 2 under root 3 plus 1, that is 1.2 into under root 3 plus 1 in meters. So the height of the base with the given conditions of the angles as 30 degree and 60 degree, 60 degree and 45 degree, and the height of the tower as 1.2, the height of the given base comes out to be 1.2 into under root 3 plus 1. So friends, these were some questions on applications of trigonometry. We'll be learning some more questions in the upcoming videos. Thanks friends for watching Edupedia Word videos.